Hi everyone, welcome to questions on oxidation states. Now this first question is asking us to use the equation, identify which elements have been oxidized, which have been reduced, and to write down where they started and where they ended up in terms of the oxidation number. Now if we start with aluminium on this left hand side, that is an uncombined element, which has an oxidation state of 0. Now we need to go over to the other side, and there's a bit of an error in this question here. That should be a subscript 2 next to aluminium, bit of a mistake there. We need to work out what the oxidation state is on that aluminium. Now it's bonded to SO4. Now I know that SO4 is 2-, and it says that there's 3 of them, just that 3 outside of the brackets. So therefore I've got -2, -2, -2, that's -6. So the aluminium, the oxidation states must add up in total to +6, because then -6, 0 overall. So I've got to think, right, I've got 2 lots of aluminium, so what should the oxidation state be on each aluminium to make +6, to balance out that -6? Well, that means the answer is going to be +3. So going from 0 to +3. Well, now I have to think, is that being oxidized or is that being reduced? Hopefully we know that that means it's been oxidized. An increase in oxidation number, it has been oxidized. So we start from 0 and we go to +3. Now we need to find an element that's been reduced. So if we have a look here at, let's say, this hydrogen that is here. Now within sulfuric acid, again, I know that SO4 is 2-. So then, again, I need the hydrogens, with which there's 2 of them. So both hydrogen, those oxidation numbers must add together to give me +2, to then balance out the -2, so it's 0 overall. So therefore, that must be +1. So each hydrogen is +1, so the oxidation state on hydrogen is +1. Now, if I then go to the other side, where hydrogen is there, it's an uncombined element, so therefore that's an oxidation state of 0. We go from +1 to 0, so a decrease in oxidation number is a reduction. So hydrogen, again, we could have H2 or H+, whatever it might be, goes from +1 to 0. Now some people make the mistake of saying that, okay, well hydrogen, the oxidation state is +2. Well no, for the H for 2 hydrogens, it's 2+, yes, but we're asking for just a single hydrogen, so it should be +1. Now I know in the answer there, the element reduced, it has says you can have H2. They're just giving you an allowance. Technically you should just say hydrogen, or you say just a H. Okay, and same again, we've got another equation there, redox reaction. Again, we've got to decide what's been oxidized, what's been reduced. Well, let's have a look. So if I start off with zinc, I've got that zinc is an uncombined element, so we're starting with 0. Then if I go to the other side, I have zinc that is here, bonded to an oxygen. Well, I know that oxygen, unless it's in peroxide, then oxygen is -2. So therefore, what does the zinc need to be to then balance that out to then make 0 overall? Well, zinc has to then be +2. So going from 0 to +2, that's an increase in oxidation number, so therefore that has been oxidized. So we have that there. And then I've got to look at something that's been reduced. So I've got some oxygens, I've got carbon, and I've also got calcium. Now, it could just be a case of working through and thinking, right, I've got to do it for every single element that I have. If I quickly just have a look through, then clearly, hopefully, what we can determine is that it's going to be carbon. Okay? And we're going from +4 to +2. Now, let's have a look at how that's actually going on. So if we look at carbon here, now again, I know that oxygen is -2, so that's -2, -2, -2, because there's a little 3 after the oxygen, so there's 3 of them, so that's -6. Calcium is in group 2, so no, that's a +2. So got -6 + 2, that's -4. So what does the carbon have to be to balance that out to get 0 overall? Well, it's got to be +4. And then if I go over to the carbon that's here, Oxygen, again, I know that oxygen is -2. So therefore, what does carbon have to be to make 0 overall? It's got to be +2. So +4 to +2, that's a decrease in oxidation number, so therefore that's been reduced. Okay, so hopefully that's all okay. Again, make sure you just practice it with these sort of questions here. There's not too much difference they can ask you. Obviously, make sure you know what a redox equation is, redox reaction is, and then have a bit of practice. Okay, so that will do us for today on oxidation states. See you next time.